Hello all, today in this video I'm going to make a continuation of the previous video only. So previously we have worked with the email spam detection algorithm with several machine learning algorithms, and in this video we are going to work with another machine learning algorithm which is GRU. So previously, we have worked with the RNN, LSTM, BiLSTM, and from that we concluded that BiLSTM is providing better results when compared to this LSTM and RNN. So in this code or in this video, we are going to check whether the other than these models, whether GRU is providing better results. So for that, initially the other details are same only, but we can just see a quick overview. So first we are just loading our data set. This data set we downloaded from Kaggle. You can just give us publishing email detection. Kaggle means you will get this data set. So this data set is having nearly three columns like unnamed, email text and email type. So we are checking whether our data set is having null values, and since it is having some null values, here you may notice that the 16 is the null values. So to reduce that, we are using the filna function. Then we are pre-processing our data set. Before that, we are determining the x variable and y variable. Here the text saves as the x variable and label serves as the y variable. Within the text we are calling the email text, and within the labels we are calling the email type, and we are using a label encoder function. Within this label encoder function we are calling the labels. Then this is an optional only. We are making a plot of within the email type. Email type is the label thing, right? So it is having nearly two classes, since it is a binary class work which is safe email and phishing email. So we are just making a plot to check the counts which email is having some greater counts. So in this plot, we get to know that when comparing to this phishing email, see if the email is having some better data, that is some high data. Then we are using the train test split function to determining the values like x train, x test, y train and y test with by using the labels and text and labels with the test size as 0.2, that is 20% will be allocated for testing and remaining 80% will be allocated for training. And then previously the vectorizer we just use for only the y data. Here again we are using a tokenizer for the x data, because we have to convert it into integers, and also we have to check whether it is having some equal length. For that we are using the tokenizer and pad sequences. This pad sequences output will only used in every models. So the first model we have used is RNN. So the layers within this RNN is sequential, embedding, simple RNN, dropout, dense, optimizer with the learning rate as 0.01, and then we are fitting the model. Why I'm just moving fast, because already we have made a previous video. So if you want some clear description means you can just check with the previous continuation video. So for this we have worked for 10 approaches, and we have got accuracy, loss, validation accuracy and validation loss. So with the same RNN code we worked with some different criterias, like without using dropout, without using this learning rate, then changing this learning rate, then changing the dropout value. So initially we have given like 0.5, no, then like we have given tested with the 0.4. Likewise, we have made some differentiations and we have worked, and we have also compared it. So you can just check the previous video to view this. Then again we worked with the LSTM. So with every models the only thing that will change is the layer. So previously if you say means in this place it will be like simple RNN, here it is LSTM. For BiLSTM also the same thing, but it will add some bidirectional also with LSTM. So in this code we are going to work with the GRU. Here also the same thing. In place of the other layers, here we are replacing it with the GRU, and all others are same only. Here we are using the Atom optimizer only, not any user defined learning rate is given over here. Then we are training it for nearly 10 approaches, and we have got an accuracy, loss, validation accuracy and validation loss. Based on this, we are making a comparison. So this is the comparison plot. This comparison plot shows that when compared to this blue color, so this some white color, this is only GRU. So it is more, it's not as high than BiLSTM, but it is near to BiLSTM, because this green color is the BiLSTM, this one is the GRU, so it is near to BiLSTM, but BiLSTM only still is taking the first place. Then comes the GRU, then only LSTM, and finally RNN. In the next video, we will be working with another deep learning algorithm which is CNN, and will make a and comparison with the other models. Thank you.